All right, what's the difference between inverse square law and direct square law? They're two different formulas. How do you know which to use and when? So just going to do a quick little talk on that. All right, here's your two examples, inverse and direct square. Some of the differences you can see right away is the inverse square law uses I's for intensity. The direct square law uses MAS. The D's on each formula are different. So if you can see on the inverse, I1 is on the top here and D2, so the numbers are inverse. Direct square law, it's direct. MAS1 and distance 1 are the same on both sides. Okay. Which formula to use? Well, basically, you just have to decide using the keywords in the question, is this question asking me to calculate for inverse square law or direct square law? Knowing when to use which formula is sometimes the biggest challenge. So I'm going to show you how some tips on how to figure that out. So for the inverse square law, it states that the intensity of radiation is inversely proportional to the square of the distance between the X-ray tube and the image receptor. Anytime you are looking for a radiation dose at a new distance, and as long as you know the dose at the original distance, here's your formula. This is what you're going to use. So if the question is asking you to calculate for a new dose at a new distance, it's usually going to be the inverse square law. Okay. Your inverse square law is going to have some sort of radiation intensity, a dose, or an exposure. So if you see the term intensity, that's your keyword that it's going to be the inverse square. Some examples here of radiation exposures that you might see in these type of formulas are sievert, millisievert, microsievert, or grays. You get the idea. They might be sort of a mix of each depending on what's there. Just some tips. In radiology, if the distance is decreased, so your tube or your source is getting closer to the patient, their dose is going to increase, as well as yours. If you get closer to that C-arm while it's running, you're getting more dose than if you step back. If the distance is increased, so if the SID is increased, the tube to the patient's dose will decrease. Same with you. In the fluoro room, when the radiologist is fluoroing, what's something you can do to reduce your dose? Step back, increase your distance, right? My hint or my cheater, because I don't use a calculator in my real world settings, but if I'm trying to sort of estimate how much it'll increase or decrease, it's usually about 4 times. So if the distance decreases, intensity goes up on an average about 4 times. If the distance increases, then it's going to go down by about 4 times. We'll show you that. One thing I want to make sure and stop here and mention is that you need to know centimeters. A lot of us use the terms 40 inches or 72 inches when we're talking about setting up for exams, but the ART board exam uses centimeters or meters for distances. So I would suggest making sure you know that 1 inch is 2.54 centimeters. If you can, try and just memorize at least the 40 inch is 100 centimeters and 72 is around 180. What are those in meters? So those might be some key ones that you'll want to pay attention to.